Good day, learners. Welcome back to our mathematics class. In today's class, we are going to be looking at series. If you could recall, in our previous classes, we've discussed sequence and the type of sequence which we call arithmetic progression. Today, we are going to look at series. Just before we move on this topic, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. And don't forget to share and like my class. Now, before we now venture into series, if you have not watched the previous videos, kindly go to the description below to watch the previous video. Now, what is series? Now, a series is the addition of the terms in sequence. When the terms in sequence are added together, the result is called series. Let's take for examples. The above are series A to C. This series can be divided into two. One, infinite series. Two, finite series. If you look at the A and B, you can see this series, after their addition, they keep continuing. We have three dots after them. It means that these terms cannot be added, meaning that this total series cannot be gotten. So this type of series is called infinite series. We cannot determine the total sum. But for the C, this one is called finite series. But here, we have the last 10, which is 21. So the sum of these 10 can be gotten. The total sum can be gotten. So this type of series is called finite series. Now, from these types of series, we can now look at the sum of an arithmetic progression. Example 1. Find the sum of the first 200 even numbers. Don't forget, even numbers, those are numbers that can be divided by 2 without no remainder. So the even numbers are 2, 4, 6, 8, 2. Then we can have, we are going to 200, we can have 196, 198, and 200. So since we have the last digit, which is 200, now find the sum. To put up the sum, we're going to have 2 plus 4 plus 6 plus 8 plus 2 plus 196 plus 198 plus 200. Definitely, this type of series is called finite series because we can find the last term here to be 200. Now, if this is a finite series, let me say this is a sum of 200 terms. Call this one equation 1. Fine. Okay, reversing equation 1, let's reverse equation 1. We are going to have S200, that is the sum. When I reverse this way, 200 will come forward. So let's look at this series. 2 plus 4 plus 6 plus 8 plus 2 plus 196 plus 198 plus 200. That is our equation 1. Now, if I reverse this to turn it upside down, definitely we have something this way. 200 plus 198 plus 196 plus 2 plus 8 plus 6 plus 4 plus 2. And this is our second equation. So let's look at what is going to be resulted to. In reversing it, we have 200 plus 198 plus 196 plus 2 plus 8 plus 6 plus 4 and plus 2. Okay, let us now add equation 1 and 2 together. Addition of equation 1 and 2, s plus s, we have 2s 200 is equals to 2 plus 200, 202, plus 4 plus 198, 202, plus 6 plus 196, we have 202, plus, then we continue to add until we now get to the end, plus 200 plus 2, 202. You can see that we are having the same value, 202. And don't forget, how many tens were we given? We were told to find 200 even numbers. From here, we can have 2s 200 is equals to, the number of tens we are going to have here is going to be 200. Then multiply by each of the, which is 202, 202. They are the same, just pick one, 202. So from here, I need to get my S200. I have to divide both sides by 2. So I have 2S200 divided by 2 is equals to 200 multiplied by 202 divided by 2. 2 cancel 2. We have S200 is equals to 2 here, 1, 2 here, 100. So when we multiply, we have 20,200. So the sum of the first 200 even numbers is going to give us, their sum will give us 20,200. So this one will now be useful for us to get the sum of an arithmetic progression. Now let's move on to sum of arithmetic progression. Now, if you can recall in our arithmetic progression, our first term is denoted as A, then second term A plus D, the third term A plus 2D, then till we move on to the last term. And the last term is denoted as UN. But in this case, our last term will be denoted as L. Now, but a letter, the term before the last term is going to be L minus D, while the last term will now be L. Okay, let's find the sum and turn this to a series. Sum equals to A plus D plus A plus 2D plus 2 plus L minus D plus L. Let's say equation 1. Fine. Let us reverse this equation 1. Reversing equation 1, we are going to have L plus L minus D plus, so we have A plus 2D plus A plus D plus A, equation 2. Add equation 1 and 2. Add equation 1 and 2. We are going S plus S. We have 2S is equals to A plus L plus A plus D plus L minus D plus T. We now have the last term here, which is what? L plus A. Okay? So 2S is equals to A plus L, then plus D minus D cancelled. We're going to be left with A plus L, then plus, till we get to the last one, A plus L. We interchange this. Now, fine. If you can recall in the example that we did, we're taught to find the first 200 terms, meaning we have total of 200 terms there. Here now, we are not specified on the number of terms here. We represent it as n, as you know, as the number of 10. So we have 2s is equals to n, number of 10, multiplied by the common factor, which is A plus L. Now I need my s, I have to divide both sides by 2. 2s over 2 is equals to n, open bracket, A plus L, close bracket, over 2. 2 cancel 2, s equals to n over 2, open bracket, A plus L, close bracket. Now, this is the first equation in calculating sum. Sum of arithmetic progression equals to n over 2, open bracket, A plus L, close the bracket, where n is the number of terms, A is our first term, and L is our last term, which we represent as UN in our previous lessons. Our sum equals to n over 2, open bracket, A plus L, close bracket. And if you could recall that our last term, UN, can also be written as L. It was given as A plus open bracket n minus 1 close bracket D. So anywhere I find L, I'm going to put in this value. So here I have S equals to n over 2, then open your brackets this way. I'm going to have A plus my last term is A plus bracket n minus 1 close bracket D. So we have n over 2, open your bracket, A plus A, 2A plus n minus 1 close bracket D. So this is sum. So if this is our equation 1, this is going to be our equation 2. So we have two formulae for calculating sum of an arithmetic progression. If you are given a last term, this equation 1 is a perfect equation to use. But if you are not given and you are given a common difference, and to find the sum or the number of terms, and sum is being mentioned, we are going to make use of the second equation of this arithmetic progression, which is the sum. Before we now move on application of this formulae, if you have not subscribed to this channel, kindly do so and click the notification bell for my subsequent content. So let us move on. Example 1. Find the sum of the first 20 terms of the arithmetic progression. So this is the arithmetic progression, but we want to find the sum of the first 20 terms. Sum of the first 20 terms. So from here, our first term here, A equals to 16. Our common difference, D, since in arithmetic progression we measure common difference, is going to be 9 minus 16, which is going to give us 7. That is minus 7. Now our number of terms, you have been told the first 20 terms. Number of them is 20. So we want to find the sum. Since you are given a common difference here, we are going to make use of the second formula that says S equals to n over 2, open your bracket, 2A plus open bracket n minus 1, close bracket D. So our sum equals to 20 over 2, open bracket 2 multiplied by our first term, 16 plus number of terms, 20 minus 1, close bracket. Our D, minus 7. So 2 here, 1, 2 here, 10. So we have 10, open bracket, 2 times 16, 32, plus 20 minus 1. So we have 19. So I'm going to have 19 multiplied by minus 7. So here I have 10, open bracket, 32, plus times minus, I have minus 19 times 7. 19 times 7 we have 133. Let us take away, our sum is going to be 10, open bracket, 32 minus 133, we are going to have 101. 101. But in this case, it's going to be minus 101. So when we multiply it, our sum will be minus 1010. Example 2. The first and last terms of an arithmetic progression are 0 and 108. If the sum of the series is 702, find question A, the number of terms in the AP. Here, they said the first and last term. First, don't forget, noted as A, last term as what? L. So first term, A, equals to 0. Our last term equals to 108. So if the sum of the series S equals to 702, find question A, the number of terms of the AP. You are given last term here. Definitely equation 1 is the perfect equation, is the perfect formula to use. That is, sum equals to n over 2, open your bracket, A plus L. Our sum here is 702 equals to, our n is what we are looking for, over 2, bracket, our first term, 0 plus 108. So we have 702 is equals to n over 2. 0 plus 108, we have 108. 2 goes here, 1, 2 goes here, 2 in 10, 5, in 8, 4. So we have 702 is equals to n times 54, 54n. I need my n, I have to divide both sides by 54. 702 divided by 54 is equals to 54n divided by 54. 54 cancel 54, n equals to 13. So question A, our number of terms equals to 13. Now question B, the common difference between them. To find the common difference, you can use two formulae. Either you use our normal formula that says last term is equals to A plus open bracket n minus 1 close bracket d, or you use this second formula for sum. Either one, you are going to arrive at the same answer. Let us use this one first to get our common difference. Our last term here is 108 is equals to our first term A, that is 0, plus number of terms that we got, that is 13 minus 1 bracket d. 108 is equals to 0. 13 minus 1, we have 12. 12 times d, 12d. Divide both sides by 12. We have 108 divided by 12 is equals to 12d divided by 12. So d equals to, our d equals to 9. So using this formula, we arrive at 9. Also, since you are told to find the common difference, you can also use this formula of sum, which is the second formula of sum of arithmetic progression. Applying the second formula, our sum is 702 is equals to the number of terms that we got, that is 13 over 2, open bracket 2 times our first term is 0, plus number of terms 13 minus 1 close bracket d. That is the common difference we are looking for. Here, 702 equals to 13 over 2 bracket 2 times 0 we have 0, 13 minus 1 we have 12, 12 times d we have 12d, then 2 here 1, 2 here 6. So 702 is equals to 13 multiplied by 6d. So when we multiply this, 702 will give us 78d. Let us now divide both sides by 78. 702 divided by 78 is equal to 78d divided by 78. This goes d in this. Our d equals to 9. So when we look at this, we are able to get the value of d using either the last term, the nth term of an AP, or using the second formula for sum of arithmetic progression. Now, you can see how easy this is. My dear students, this is the first lesson. In the next lesson, we are going to be looking at the sum of arithmetic progression and how to apply it to our real life. Before I leave the class for today, don't forget to subscribe to my channel and click the notification bell for my subsequent classes, and also like, comment, and share to your loved one. I will see you in the next class. Thank you.